Hey guys, this is Professor Janacek. I want to go over finding limits using the squeeze theorem. First, let's go over what the squeeze theorem says. Let's start with three functions, f, g, and h, and they are functions such that we know that f of x is less than g of x, which is less than h of x for all x values near some value a, except of course possibly for x equal to a. At a, we don't know what's going on, but as long as near a, f is the smallest and h is the largest and g is there in the middle. Then our squeeze theorem says that if I know the limit of f of x as x approaches a, and it happens to be the same as the limit of h of x as x approaches a, and we'll call that limit L. So notice I'm looking at the limit of the smaller one and the larger one. Those are the same, we'll call that L. Then it turns out that the limit of g of x as x approaches a, the one in the middle, is also the same. So if I could squeeze g in between two functions f and h, find those limits. If those limits are the same, then g must also have the same limit. Let's take a look at an example. Let's find the limit as x approaches 0 of x squared sine of 1 over x. Oh my goodness, let's take a look at this. This is kind of crazy. So to start off with, we know that, let's just start with something simple. I know that sine is bounded by -1 and +1. So sine of 1 over x is also bounded by -1 and +1. So -1 is less than or equal to sine of 1 over x, which is less than 1. Then I need to get x squared times the sine of 1 over x. So let's go ahead and multiply all this by x squared. X squared is a positive, so that means this is completely acceptable. Does not change my inequalities one bit. Okay? All right. Now let's take a look at this stuff. I also know the limit as x approaches 0 of -x squared. Because this is polynomial, I can simply evaluate -x squared at 0 and we get 0. And similarly, the limit as x approaches 0 of x squared is also 0. Oh, well, look at that. I have the limit of the item on the left is equal to 0, the limit of the item on the right is equal to 0, which means the limit of the stuff in this middle must be the same. So now I can see that because I've squeezed my function into the middle of these other two functions, then I can confidently say that the limit as x approaches 0 of x squared times the sine of 1 over x is also equal to 0. Isn't that lovely? Enjoy!